Okay, it's me again, Jean-Louis Van Bella. So I'm a bit of an amateur, and as I'm on holiday, I'm a bit of a role. I produced a lot of videos on what I think is a classical interpretation of the weird science of quantum mechanics. I'm interested in it for the same reason as you're probably watching this video is sort of what is mass? Can be explained by something else? What's the essence of nature? How do mass and charge and all that relate to each other? So I have a rather simple model of an electron and a proton, and from there you can build the world. Also, its antimatter counterpart, and I will say a few words about my hypothesis for most of the matter seems to be dark matter, and most of the energy in the universe seems to be dark energy. So I have a hypothesis for that, and that's a fun one to talk about, but it's for the end of my lecture. So hopefully you will be more motivated to listen a bit longer to my nonsense. The nonsense is actually, I do have a manuscript actually, and there, I start, and I would like to rewrite it. Where is it here on academia somewhere? Yeah. Um, the Emperor Has No Clothes, a realist interpretation of quantum mechanics. And I start with a few simple, what I think is simple, mathematical things you need to know. And when I talk mathematical things, I'm not talking about the circumference of a circle is 2 pi r square, is 2 pi r. Um, the surface of a circle is 2 pi r squared. I'm just thinking about wavelengths. I'm going to talk about it in a moment. But in that book, I do start with like special relativity theory. I think it's a bit of a special relativity theory as compared to general relativity theory. These are very two different beasts. I would say special relativity theory is correction to Newtonian dynamics. It's about kinematics, about how objects move, and this necessary correction factor that you need to apply when you think about motion at very high velocities. In my story here, and that's one I'm gonna talk about now, I have a bit of a joking story about God that creates the world and then thinks about how he should go about that, and he takes a few engineers in his team, like Einstein and Hendrik Anton Lorentz and a few others, and Newton himself, of course, the old Newton. And he says basically, infinite velocity, a bicycle, a spaceship, a galaxy, or even an electron or a proton that moves at infinite speed, really infinite speed, that doesn't make sense logically. Why not? Because that electron, that proton, or that bicycle is everywhere and nowhere at the same time. Yeah, if it travels at infinite speed, it means that it's in an infinitesimally small time interval somewhere else, anywhere else, basically. So he says, we need to be absolute infinity. The velocities cannot exist in my universe because it would be a universe that cannot possibly exist, and or at least that no one can make sense of. So how can we put a speed cap on bicycles and spaceships and galaxies? Um, things with very different mass, but I need a formula, sort of a factor that makes sense, and that's sort of where, fortunately, when I wrote that, I played a bit less with Desmos than I do now. It's an online graph calculator, and visualize things is also nice now because you have it in 3D. But that's sort of how it looks like. You would have a factor if you want to. We have an interval theoretically from 0 to infinity for velocities, and I said that's logically inconsistent because then you talk about objects of particles that are everywhere and nowhere at the same time. Our world would not make sense. a previous video, I talked about, the direction of time in the same sense. If we allow time to go back, you don't get very well behaved mathematical functions, and it becomes impossible to, express physical laws in logic and in mathematical formulas. So the factor actually is the what I show here. This blue arc is actually the inverse Lorentz factor, and you can see if we want to reduce an interval for any variable mass or velocity from 0 to really infinity, then which doesn't make sense. We want to reduce it to an interval between 0 and some finite value, the speed of light for light, and well, basically the speed of light for everything that moves, photons, protons, and yeah, things that have a mass, a rest mass, I would say, and a rest mass is things that have energy. Particles have energy, and so here on this graph, I make the rest mass move, oscillate between 0 and 1. I could make it oscillate between 0 and some other very large value, but let's say that we have a mass unit which is normalized, and or that the largest object is normalized in such a way that the largest object in the universe and the largest galaxy or universe, whatever, that moves has a mass of 1. You can see we get this very special nonlinear red graph, and so the question then is, and that's sort of what triggered my my research a little bit, and the story I make about how natural special relativity theory actually is that can we imagine, if we look at the origin of mass, what is mass? In special relativity theory, when we talk about general relativity theory, we talk about gravitational and structure of the non-Cartesian structure of the universe. But in kinematics, mass is basically a measure for the inertia, the resistance to a change in the state of motion of something, and that something in our everyday macroscopic world, these are objects that have a rest mass, a proton, an electron, and then all the composite particles that you make out of it, atoms and then molecules and then larger chemical structures and composites and whatever, and you have, and so that's gonna obey that law. The thing I'm wondering is, and that's sort of where I got inspired a bit by John Wheeler, who was a famous physicist. He never got a Nobel Prize, unfortunately. He had this program that he said, we need mass without mass models. We need to explain where this inertia to a change of state and in motion of an object comes from. Even if a photon has a relativistic mass, zero rest mass. So I was thinking, like, in a world where we have electromagnetic fields, and we also have charges. There's no other fundamental physical concept that appears in Maxwell's equations, which are pretty complete. They talk about charge densities and electromagnetic fields, and so I'm thinking, like, can we imagine what Schrödinger called, like, by the Zitterbewegung charge? He imagined that an electron and a proton actually, their mass, their rest mass that they have, comes from what I would say is a naked charge. A naked charge is a charge without any other properties except for its charge, plus or minus 1, fundamental constant of nature expressed in Coulomb, and that I will show in a moment. Yes, some size, and this is where I want to go to this graph here in my notebook, where people say is very confusing, but I'm talking about let me take some color to mark things here. This one, for instance, this graph. I said your function is gonna collapse into basically for an object with zero rest mass here, is gonna collapse either into this asymptote for a photon, the mass of a photon. We say the mass of a photon. Well, it's the equivalent mass. It's E divided by c square. Um, that's um, that's gonna be that can have any value. We can have very low energy, so only a little bit more than zero, but we can have very highly energetic photons. So a photon really, when you apply a relativistic mass formula to it, then it can be anywhere on this line. And now the particular thing is in the model I have for an electron and a proton, I'm thinking like, okay, a charge oscillates and it's charge in motion, and then I have this very simple model where I say the energy must be equal to mc square. At the same time, we have the Planck-Einstein relationship, where we also say the frequency, I'll talk about that frequency, is the h bar, the Planck's unit of action, divided by 2 pi. We can have h bar over h. And out of that, you can do the substitutions. If you imagine that, a point-like charge, I call it the Schrödinger charge, or the Titelbewegung charge, as he called it, goes round and round and round at a certain frequency, an orbital frequency, and that takes a certain time to make one oscillation, one rotation. And that's where you have a different concept of wavelength. It's the wavelength becomes really the circumference of that circular orbit, and that's what I've explained at length in previous videos, and that's my main paper on ResearchGate, is that de Broglie was right. Proton and electron, they have a frequency, everything has a frequency, and it's Heraclitus, you might say, charge, or which has no mass but some size. That's the anomaly in the magnetic moment, and the magnetic moment of an electron, indeed. Because it has a certain size, but it has no rest mass, and so it zips around at the speed of light, and that motion, a force acts on a charge. We always think from Newton, force acts on a mass. But yeah, that's for gravity. But the electromagnetic force, we should always remember, acts on a charge. Has nothing to do with the mass concept. And so you get the Compton radius of an electron, and so the scattering radius, more or less, I will say, because I will talk about why the sky looks blue, etc. The photon energy does make a difference, and that's sort of in theoretical Compton scattering models, something that is not taken into account, but can easily be done in this simple model. I also have a proton model, and that's sort of where it's a bit more difficult. This two-dimensional oscillation is kind of easy to imagine. We can also imagine that there's an oscillation in a third dimension, and so then the Planck-Einstein relationship, as you know it, to explain black body radiation, is actually the energy of some energy state should always be a multiple of h bar times the frequency of whatever gives that energy state its energy. And then you get the proton radius, that's 4 times h bar divided by mc. I like to express it in and that's something I'm going to show now. Let me clean up my sheet. It's sort of you have a very close analogy there, just between matter particles, I would say, or elementary matter particles. So they are an oscillation of charge, and we get a radius, which I said, a radius of a circle, and the circumference of that circle, you can think of it as a circular wavelength. We get h bar divided by mc, which is equal to h bar times c. And this is, I don't remember its value, but divided by the energy. And you have then something very special. Talked about that is, we usually think that the energy in oscillation is indeed, and it is the case, of a mechanical oscillation, is proportional to the square of the amplitude and the square of the frequency. We have that here, but we also have that Planck-Einstein relation, which then shows that basically we have an inverse proportionality between the Compton radius, as I call it, and the energy. And we only have two values for the electron charge and the proton charge. And the electron charge and the proton charge are not the same as the electron or the proton. That's the fundamental mistake that is made, I think, in modern quantum physics, that they identify and they think of an electron and a proton as being this homogeneous thing. No, it's something that it's charge and oscillation. But you have for photon wavelengths, they are linear features. Photons are linear things. I depict it here. I'm going to talk about it in a moment. We have the same thing. The wavelength, or the reduced wavelength, is h bar times c divided by the energy. And the full wavelength, if you multiply by 2 pi, is hc divided by I. Let me say a few things about first about amplitude. What do we mean with the amplitude of an oscillation? Intuitively, um, this inverse relationship between this inverse proportionality between the Compton radius and the energy does not make sense. You think higher energies, higher amplitudes, but that's true and that's not true in terms of what we talked about. Let me clean up my sheet again. Of course, the my model of the electron and proton is not some kind of mythical, you know. I'm not modeling the elasticity of space-time in one dimension or two dimension or three dimensions, like that's sort of what you get fed when you register for an online course in quantum mechanics. These oscillators. No, actually, a ring current, as I show in my papers, generates basically the electromagnetic field. A ring current is a tiny magnet. The electromagnetic field is such that it's also going to obey the Planck-Einstein relationship, just like for superconducting currents. The magnetic flux is going to come in discrete units that are characterized by Planck's unit of action. And so there's nothing magical about this model of mine. We do talk about the charge that is going around and around, creating an electromagnetic field. It becomes a tiny little magnet, has a magnetic moment, and I will talk a little bit about, you will say a homogeneous current. A ring current is something else than a point-like, but not infinitesimally small electric charge going around and around. What happens when you look at very close scales? I'm going to talk about it in a moment. In any case, what I wanted to say about the photon is a little bit a question for you to think about, to make it fun also. You have these animations where a photon is indeed being represented as something that consists of an electric and a magnetic field vector. I could pull up a Wikipedia animation, and then sort of that electric and magnetic field vector, their amplitude goes from 0 to plus some value, and then back to minus some value, and then back to 0. You may wonder, where is the photon and where is the energy of the of this electromagnetic field? It is, of course, in the full cycle that it makes. And the interesting question that you will have is, well, at the 0 point, where is the energy then? There's no electromagnetic field at this specific point in time. Well, the answer there is that's indeed the strange thing and the big difference between light particles like photons and also neutrinos. Yeah, you need to look at the cycle, and that cycle is associated with a wavelength and a specific time interval t, where the photon, will travel from this point A to this point B. And that's just what it is. And you could say, is that then the length of a photon? Is it, this thing jumps from here to there and then to there? No, I think it's point-like. So at this point, we have the photon at a specific point in time, and at that point, its electromagnetic field is just 0. But of course, when it gets absorbed by an electron, when the electromagnetic field, for instance, at this point is quite strong and messes, it's going to interact, it's going to mess with the electromagnetic field of an electron or a proton, then then the whole energy of that photon gets absorbed, or what I prefer to say, the physical action associated with that cycle. Physical action is a physical concept. It's a force times some distance, the reduced wavelength times a time interval. And that's a similarity between matter particles and light particles. The interesting question was a neutrino. Well, if you think of a proton, or I won't talk about that. Neutrons, I think of some kind of two-body problem. You have a positive and a negative charge in some kind of dance with each other. Um, it's going to be an oscillation in 3 dimensions, and so neutrinos are going to be like photons, but not planar things, 2 dimensional things, with an electromagnetic and field vector always being in the same plane. But in 3 dimensions, and that probably explains why, according to measurements, neutrinos don't quite attain the speed of light, because one of the components of in this 3 dimensional oscillation is actually in the plane of motion of that neutrino. I want to say something which strikes me, and because I'm going to be talking about dark energy and dark matter, is in most illustrations, like on Wikipedia, you will actually find a figure like this, with the electric field vector and then the magnetic field vector. There's a fundamental asymmetry in the electromagnetic force, in the sense that a photon that moves in this direction is really like this. There's a 90-degree rotation in a very specific direction. It's not a photon like this. No, and actually, what I find is that this is actually a mirror image of what is happening. You should remember the geometric convention. There's a right-hand rule for the coordinate system, both in physics and mathematics. Your orientation of your x, y, and z axis is gonna be as I put it here. This is the x-axis and this is the z-axis, because that obeys the plus y direction is not here. And then you have the second convention, which I will use. Actually, you can say imaginary unit. It's a rotation operator. It folds the uh, x-axis into the y-axis. And we know that the imaginary unit, you can define it in terms of clockwise rotation or counterclockwise rotation, but it doesn't help very much, because then you need another conventional. Well, are we looking in the direction of propagation of the particle in the wave, or are we looking from where the particle came from in the other direction? So I prefer to have that mathematical convention, which is that the imaginary unit I rotates the x-axis into the y-axis, and then you have this beautiful formula where basically your electric field is going to be related to the electric field vector in exactly this way. It's going to be at an angle of 90 degrees, but written as a minus I. So you rotate against the direction from x to y, and the magnitude is going to be the magnitude of the electric field vector divided by c. And so you have to keep your wits with that. Why do I say that? Because modeling an electron, we can really write it as like this, a phase times this rotation operator, and then we have this beautiful formula for which there is actually, Feynman develops a beautiful calculational proof of that, but I'm not going to go in a plus E times the sign. And so here we have indeed, a very easy wave function that represents the electron in terms of two linear oscillations. We know cosine and sine are basically the same function, but with a phase difference of 90 degrees. You don't have that for a proton, or you would have it. Let me clean this up. And that's why here. Because in a 3-dimensional oscillation, goes up and down, it goes back and forth, and it goes sideways. You would need another imaginary unit in a different, so another rotation operator, which would rotate. And this is interesting here. You can, and I'm going to talk a bit about quaternions here. You can have two interpretations of this. Either you say that generally this new imaginary unit will rotate the xy plane onto the plus z axis. So I'm talking about a rotation of the plane. Now this plane, we have it here, the EB plane. Let's call it that way. And then we don't care about the azimuthal angle, I would say, of the J operator, because indeed it's very different. And mostly they will say, well, the J rotates the y-axis into the z-axis. So we have I as imaginary unit, which rotates the x-axis into the z-axis, and J, which rotates the y-axis into the z-axis. I prefer, and I think that was Hamilton's original idea, is that the I and J are orthogonal to each other, but that leaves another degree of freedom, and we don't necessarily need to specify that other degree of freedom. I'm not going to go into the detail, but probably you do need that if the B plane is a y is in the plane of the xy axis, then you get a very different. Do I put it here? No, then you get a very different interpretation of the third imaginary unit in Hamilton system, which is I times J. Here I put it. Okay, so yeah, this is also something that strikes me is most models of electrons, protons are indeed realistic models, but when you inject quaternions into it, there is a way of capturing dynamics that you cannot other ways capture. But I guess I'm doing exactly what I said I wouldn't be doing, talking about simple stuff that is of interest to the reader that is not too much into math. But I said I would start probably a book with pointing out, that let me go to the assumptions here. Princess force. Well, okay, I can go to that. A force acts on a charge, and the only experimentally measured charge that we have is the electron, is the electric charge. An electron, the charge inside of an electron and a positron does not have the same size, as the same charge as this theta-Bewegung charge inside of a proton or an antiproton. I will not talk about pair creation and annihilation. Time reversal, this is it's a very unlogical idea. Special relativity is the thing I want to talk about. Is modern quantum theory really gets caught in this thing. We think abstractly in terms of probabilities, and the Copenhagen or mainstream interpretation says basically, well, probabilities are what they are, and we can't reduce them to physical processes. So basically, they leave the statistically deterministic framework of the old quantum theory, and that's where what I'm going to show now is where I very much agree with. Here, this is a paper, and I'm going to show you what